Hello, my name is Craig Paddy Cooper and I'm a pharmaceutical scientist, and I'll be describing my typical day-to-day activities as a researcher in the pharmaceutical science research field. One of the commonest tasks that we have is the study of and identification of possible drug candidates for common illnesses, and one of the most common illnesses is cancer. The way in which we identify possible drug candidates is primarily and firstly through a literature search, and literature search could be simply looking online and keeping abreast of current stories. One of the topics currently being talked about is the plant Artemisia, otherwise known as sweet wormwood, which has a powerful anti-cancer effect. In fact, researchers at the University of Washington have actually identified Artemisia as having 1,200 times more specific ability in killing certain kinds of cancer than any currently available drug. So the University of Washington identifies Artemisia as 1,200 times more specific in killing cancer than other currently available drugs. And this new compound, artemisinin, is derived from the sweet wormwood or Artemisia annua plant. There are many varieties of Artemisia or sweet wormwood, and the specific variety with the highest concentration of the active ingredient is called Artemisia annua. Now, what we do, we then look at other literature like this one here, Anti-Cancer Activity of Botanical Compounds in Ancient Fermented Beverages, to confirm and learn more about the plant. And this particular article says that Artemisia annua has showed the greatest activity in vitro against lung and colon cancers. So of all the plants that were studied, Artemisia annua showed the greatest in vitro activity against lung and colon cancers. In vitro means the effect on cell cultures, but it showed the greatest in vitro activity against lung and colon cancers. So the next stage is how do we obtain this drug? I typically obtain a particular drug of interest either by purchasing it online or from a reputable supplier, or extracting it from nature, or by synthesizing it in a laboratory. Well, it turns out that Artemisia is easily available to purchase in its raw plant form as leaves, and here is a picture showing Artemisia, and the actual cost works out around about for 500 grams, about £30. Next, having obtained the plant, we need to be sure about how we can extract the active ingredient from the plant, and this is a common day-to-day activity that I engage in. Here we have a paper which describes its extraction, and it says that a systematic study of the preparation for the therapeutic tea infusion was performed by Van der Kuhe and showed that nearly 93% of the available active ingredient was extracted from sweet wormwood, but only under certain conditions. And these conditions were that the best preparation method was 9 grams of dried weight leaves per litre for 5 minutes at 100 degrees centigrade. So that's equivalent to 1 gram of leaves in boiling water for 5 minutes in 100 milliliters. So there we have a simple extraction method using hot water. And this is the method that we're going to use. And this shows you and illustrates how simple some activities of being a pharmaceutical researcher are. We simply take 1 gram of dried leaves, which is about the amount you'd have in a tea bag, add it to boiling water for 5 minutes, and it extracts 93% of the active ingredients. The next question is, what is the therapeutic dose of Artemisia? And one way we can find this out is by looking at what is the therapeutic dose of Artemisia for treating other conditions such as malaria. Artemisia is commonly used to cure malaria in African countries, and according to this website, which is from malariaworld.org, clinical trials across a dozen or more countries, most of them published in scientific literature, show that Artemisia annua herbal tea has a healing rate of malaria of greater than 95%. So we see here that ordinary preparations of Artemisia tea, by actually adding Artemisia to boiling water for 5 minutes at 1 gram to 100 milliliters, has a healing rate of malaria of 95%. So this indicates that a therapeutic and safe dosage of Artemisia would be simply 1 gram of Artemisia leaves in 100 milliliters of boiling water for 5 minutes. The other thing that I commonly do as a pharmaceutical scientist is to establish the biopharmacokinetics and pharmacodynamics of the drugs that I look at. One of the characteristics is the half-life, and the half-life of Artemisia is 1.93 hours. Normally or typically after 5 half-lives, a drug will completely have cleared the body. So 5 half-lives equates to 5 times 1.93, which is approximately 10 hours. So after 10 hours, there won't be any more of the artemisinin left in the body, which means that if a person has a dosage of half of artemisinin every 10 hours, they won't undergo any bioaccumulation. The volume of distribution of artemisinin is 1,600 litres, and any volume of distribution greater than 40 litres means that the drug is well distributed in the body throughout all the cells. So artemisinin reaches all parts of the body, and it doesn't stay in the bloodstream but mainly moves out into the tissues. In this interview, I described my everyday activities as a pharmaceutical scientist. Firstly, in identifying drug candidates for the ailment of cancer via using literature review. Secondly, in obtaining the drug candidate by either purchasing it, synthesizing it in a lab, or extracting it from nature. Thirdly, what methods I was going to use to actually extract the active ingredients from the drug candidate, in this case by simply boiling the drug in hot water for 5 minutes. Fourthly, identifying the therapeutic dosage of the drug by actually looking at its dosage use for other ailments, in this case for malaria. And fifthly, in calculating the frequency of dosage by looking at the half-life and volume of distribution of the drug in the human body. I hope you've enjoyed this interview, and along the way you've learned something about how to cure cancer. Thank you.